do is on the horizontal line, we have the diameters plotted. Diameter of the bolt that we are producing. Okay. So we will have an horizontal graph here. We will have something like 5. Here we will have a limit like 5.1. Here we will have a limit of 4.9. So these are different, 3 different diameters of the bolt that you are producing. Okay. You are expected to produce the bolt that we need. Everything has to be exactly 5 millimeter in width. Okay. This is the line where you want to plot, like produce everything. But when you start producing, what is happening is, like first bolt that you produced, it will have 4.9 diameter, then 4.95, then 4.98, then some changes happen, then you have 5.01, 5.02, 5.04, 5.09, then 5.1. Okay, you start production because production has so many external factors. You said, okay, different boards have different diameter, they are having certain amount of difference. You're always targeting exactly 5, but their diameters, these dots or circles, they are different diameters of particular boards. Okay, now what you do is, now imagine you produce one full batch of bolts. Now you start measuring, there are 100 bolts. When you start measuring, what you will see is, we will make a frequency diagram now out of the 100 bolts. And you know what is frequency diagram? For example, the number of bolts that have diameter 4.9. So we will see maybe 5 bolt have diameter 4.9. Then maybe 10 of them have 4.95. Then maybe 40 of them will have 5 correct diameter. Then 20 of them will have excess 5.05, 5.09. Then some of them will have 5.1. Okay. So these are the frequency. This is called a frequency graph now. Frequency at 4.9, frequency at 4.95, frequency at 5, frequency at 0.5, frequency at 0.9, then frequency of 5.1. Okay. Just to make it easy, I will plot the line here. I will write frequency. Okay, this line, vertical line represents frequency, horizontal line represent diameter. And what we have done is, this is called frequency diagram. So out of the batch of 100, this is what you will see. Most of the materials, if your process is okay, if your process of manufacturing is okay, most of the material you will see in the center, hitting the exact parameter, exact diagram. Some will have excess radius, some will have lesser radius or diameter, whatever you want to say. So now, whenever you plot any of this, then in any manufacturing process, we have something called upper control limit and lower control limit. Okay, what is meant by upper control limit? It is the upper limit which is acceptable. For example, I establish an upper control limit here. And then I established a lower control limit here. What is meant by upper control limit? If the dimension is more than the upper control limit, it is rejected. So means this number of bolts which are at 5.1, they are rejected. Okay. and anything lower than the lower control limit, which is less than 4 point, like this line, this 4.9, this materials which had 4.9 dimension, all these materials are rejected. Okay, they are not acceptable. Now what happens is, in such batches, what we do is, we take out, we you remember the formula, the formula, if you want to write it down, just write it down. I'll show you the formula once again. Just write down the formula so you will remember. Sigma is equal to square root of, in the first bracket, x1 minus mu whole square plus x2 minus mu whole square. Whatever is the number of x's, like number of values, xn minus mu whole square divided by capital N. I'll come back to the whiteboard again, same board again. So when you will calculate sigma for this process, what will sigma give? What does sigma represent? Sigma represent for this batch of production that you have already done. Quality is already defined, like it's done. You cannot do anything right now for this. When you will measure sigma, sigma will tell you how off your overall process was from this center line. This center line is your objective, right? But you see, frequency diagram is here, some components are here, some components are here. So it will tell you, sigma will tell you how off the average of the batch was from this line. Okay, so sigma will give you this measure. This was the target line in the center. This is your overall mu. Okay, how off was it? So from manufacturing point of view, it tells you this. This gives you a distance. Okay, sigma gives you how off was your process from the desired value. Okay, now you remember, like when we were talking, like if you would have heard, Siemens is on 6 sigma, some companies are on 9 sigma. That means, see, if this distance is one single mu, one single sigma, this distance is 1 sigma. So this distance here is 2 sigma. Okay, so that means this process currently is under 2 sigma. This material maybe is at the 3rd sigma. But this 3rd sigma is crossing the upper control limit. Okay, when we say, like, this is a statement often heard, like higher the sigma level we reach, better is the process. What does this statement means? Here we see, if we are under 2 sigma, the product is acceptable. Okay, if we go to the 3rd sigma, that means the product is already rejected, it is bypassing the upper control limit. In general, that this statement when we say that the higher the sigma level, better is the process. That means you make sigma so small that six of these fit into the fixed up UCL and LCL. Right now, the width of sigma is very high. So we need to make sigma so small. This should be the size of the sigma so small that the upper control limit and this lower control limit being fixed, you should be able to fix in six times of sigma into that. So that means you should have six sigmas so small that six of the sigma should fit into this upper control limit and lower control limit. Sigma again was a measure of variability. How wrong was the forecast or how wrong the setting of the machine was while manufacturing. So this Six Sigma is always used in forecasting as well as manufacturing. Sigma is the measure of variability. So our upper control limit, lower control limit remains fixed. It never moves. The whole objective is to minimize the sigma, make the sigma so small that six times of the sigma can fit into the same upper control limit and lower control limit. Okay. Now what happens is when we do a plot, we are still on the same batch. We haven't done any improvement. So there is no change in data. So when we do the line graph of this frequency table, this is the frequency graph. So we did a line for all the frequency. Now, see, we can say different types of probability. Do you know the correlation between probability and this normal distribution graph? I will tell you. This point, this is 50% probability. Okay. Now using the same concept, I will just make this part hashed. So now we are going back to the forecast. In terms of forecast, when you are forecasting, that means you are forecasting this limit, this target number here. This is what you are trying to forecast in the forecast. Okay. Sigma is one of the variances, is the difference between the actual demand and the forecast. And this point which we have forecasted here, the sigma level that we have put as 0, 50% probability. So if we keep the stocks only and only as per forecast, we will have customer service level at 50%. We will have a chance of 50% missing the forecast, missing the actual demand. Okay, one sigma here, if we consider the original sigma, one sigma, this is this stock. If I now increase the stocks that I have kept by one sigma, when we add, it makes the confidence level or customer service level at 67%. What we have done is we know sigma is the variability in our forecasting model. Sigma we calculated from the forecasting model itself. Sigma we know is the variability. So if we keep one sigma extra stock, then we keep more probability to us. We keep more confidence level to us. We keep more customer service level to us. So these three terms are used interchangeably: customer service level, probability, and confidence level. Okay, if you keep 2 sigma now, what you will do is you will keep this much stock also more in use. Now, instead of diameter, consider this as a forecast. Like your forecast was 5,000 instead of 5, and you move to 5,200. Now you move to 5,400. So the more the forecast, more the uh, more the sigma value you will keep, 1 sigma, 2 sigma, which is a function of your forecast and the error in the forecasting model. More the forecast will keep, more confident you will be of serving the customer. So now the same principle applies here. When your forecasting model becomes more and more accurate, okay, in manufacturing, we were improving the process, reducing the sigma, reducing the variability. So now in your forecasting model, it becomes more and more accurate. So the error in the forecasting model will reduce. So the sigma will become small. So what will happen is now the sigma will become small. So 2 sigma will be like very small space. So by keeping very small stock extra, you will be able to cater to 67% confidence. Or 3 sigma at 95%. 3 sigma is 95%. So attaining the same 95% customer service level or confidence level will require lesser stock if your sigma becomes low. So with lesser inventory, better forecast, becomes smaller sigma, you can have more confidence, higher customer service level. I hope this makes sense. Like, do you get a like the major idea? What is frequency diagram, upper control limit and lower control limit, and then how it is applicable in the forecast also.
Is this sigma the same as the MAD? The
No, no, no. MAD is
Okay.
different. MAD
Okay.
is one of the measures, simplest of the measures.
Okay.
So
Because we're using the cell bell curve example for that in the book.
yeah, actually, the whole point was like if you will remember that slide, we had established MAD. There was a relationship between MAD and sigma. If you'll go back to that slide, you will see there is a table which tells the factor between MAD and sigma. Sigma is used everywhere. MAD is used in forecasting only. This sigma, variance, standard deviation, is used in every single thing: manufacturing, quality, forecasting. This is a statistical tool. Like, it's not supply chain or forecasting tool. It's a statistical tool, standard statistical tool. So that is why it was important when we were talking about MAD, you should know what is standard deviation. This sigma is called standard deviation. It's nothing else but the measure of the variability. If we are talking about manufacturing, then it is the difference between the actual product dimension than what you were targeting for. If it is talking about forecasting, it is the difference between the actual demand and what you had forecasted for that particular month. So the difference, it's a error, it's a measure of error. The whole concept is you should know this, the there are certain limits to any process that is acceptable. There are certain limits to the forecast that is acceptable. Like, you cannot just make a basic forecasting model and then you will say, okay, I will do it no matter how big the error every month is coming, I will focus on the same model. So there are certain bandwidths which are there, like anything you do which has an acceptance limit, upper limit, lower limit. So manufacturing has that, definitely. Same thing is translated into forecasting. You have an upper limit, you have a lower limit of forecasting. When you are forecasting, that is the center line, that forecast in the center line. When the actual demand comes in, that is your X value. And you monitor this data for last 12 months, you get the standard sigma that this model has been producing this kind of variance. Now to forecast for the next model, next month, you forecast them You forecast for the any of the tools, using any of the tools, you forecast for the next month. But you should know, any forecast, if you keep stocks only and only as per forecast, that means you are at zero sigma level. You incorporated zero errors, zero measure of errors. You are at 50% customer service level. You are at 50% confidence level. Okay. You should know there is a 50% probability that you will miss some customer orders. 50% customer orders will be missed if you keep the stocks only and only at the forecast. Now what you do, you want to improve at the customer service, you want to improve the probability of fulfillment of orders. What you do, you look back at your model. My model had certain error. What was the measure of that error? So if I add stocks equal to one unit of that measure, that was sigma, standard deviation, then from 50 I will go to 67%. If I add 2 sigma, it will take me to 93%. If I add 3 sigma, it will take me to 98% customer service level or probability or confidence level. Okay, this is the whole idea. But we should not just be happy. Okay, if the sigma is like 10% of your demand, so you keep 30 to 40% extra. 3 sigma will tell you keep 30% extra stock every single month, order 30% over and above what your forecast is. So this is not acceptable. You have to then go back to your original process. In manufacturing, you have to go back and look at your original process if sigma is very high. Okay, in same in forecast, you have to go back and look at your forecasting model. Why my sigma is so big? I have to reduce the sigma. If you get very relaxed, if you let things go haywire, sigma will increase more and more. Things will go out, this graph will go out more and more out of the UCL and LCL. Now, UCL is what? In terms of finance, like you can ask me, like, I can have infinite inventory, but every organization has a budget for inventory. That UCL is defined by that budget, that target. This target comes from the financial objectives, like we studied from the balance sheet. This UCL comes from the financial perspective, that you need to have a budget, upper budget for the inventory. You cannot just carry infinite amount of inventory. So that UCL is set by the finance. So you have to make your sigma so small that more and more sigmas can fit into that space between the forecast and the budget limit. So the objective is not pushing the UCL in LCL in any of the manufacturing to make space for the sigma, which is already very big. The objective is to make the sigma so small that it fits into the existing UCL and LCL. That is why we say, like some companies, they are very proud to say we are at 6 sigma. That means they have fixed UCL and LCL. They have made the process so strong that their sigma is so small that 6 of them fit between the center line and the UCL. Some companies claim we are on to 9 sigma. Forget 6 sigma, we are on to 9 sigma process. That means their sigma is so small that 9 of their sigmas fit into that fixed UCL and LCL. Okay, so I hope the relationship between the probability, customer service level, safety stock, total inventory, now it's a little clear. Like the relationship between all these things are a little clear. Because I several times saw this disconnect, that if I will say safety stock depends on customer service, then there is a certain disconnect. Okay, how is this connected? Customer service level at safety stock, how is these two related directly? Hopefully that is clear. Then I have like a few tools that will just